Welcome to the second lesson of the second module of the course on clinical databases. We have seen in the previous lessons how to select data from a database when the dataset is composed of different tables. Beside data visualization, it is in general required that selected data can be analyzed and eventually processed. Usually, the data of a single patient is spread in different tables. Now the question is, how can we retrieve data of a single patient if they are contained in different tables of the database? To answer this question, we continue to see how to combine data from different tables to extract selected data of individual patients from a large data set. We have seen in the previous lessons how to select data from two different tables and how to join them. Using the inner join command, we generate a subset of data represented in this view. Scrolling down the table, we can see that patient age has been calculated for each visit, up to the almost 15,000 visits in the database. Once we have retrieved this information from different tables for each visit, we can now order the rows of the table visits by patient. Using the fiscal code and by visit date to list the visits of each patient. To order these data, we can use the SQL query reported in the top panel. The instruction we used is the order by with argument, fiscal code, and visit date. Please note that these data come from two different tables, patient data CVS and visit CVS. In this way, we can see how several visits are present in the database for a given patient and how patient age is computed for each visit. We can see in a more extended window, as an example, the follow-up of a patient. As we can see here, the patient highlighted in red has been followed for almost 7 years. Let's see now how to inspect and how to analyze the clinical data of this patient population. In particular, there are parameters of laboratory tests that are linked to visits table, and data in visits table are linked to patient data. To evaluate renal dysfunction and the evolution of the disease with time, it would be important to inspect laboratory data during the time of follow-up for an individual patient. For this task, it is necessary to combine data on patient data table to that of visits table and then to that of blood test table. One of the parameters used to evaluate renal function is indicated here as eGFR. That is the estimated value of glomerular filtration rate. Now we would like to evaluate the changes in renal function with time in a patient. To this aim, we need to join the three tables, as shown by the query on the top panel, joining the patient data table with the visits table and the blood test table. We can select the column of fiscal code, eGFR, and visit date. As we can see, these three columns come from three different tables, and the values in the fields are related to a given patient for a given visit and a given eGFR value. Using this data set, let's see now if we can evaluate the loss of renal function in terms of changes in eGFR values over a period of time. We can select a patient that we know that has a long follow-up time. Let's see the SQL query we used for selection of different fields in the three tables belonging to the patient that has the selected fiscal code. After joining the three tables, we select the column of visit ID, visit date, and eGFR for the selected patient. The result is shown in the next slide. As we can see here, we have now only visits with complete data set for this patient. The values reported in the table represent the first rows with visit date starting in 1998. Let's see the end of the table in the next screenshot. There are 87 visits for this patient and related lab test results from 1998 to 2012. Now we would like to visualize this dataset graphically. To this aim, we can export these data using the function export and create a text file with the format CVS. This is the format of a file containing comma-separated values, and that can be opened using Microsoft Excel program. Opening the CVS file in Excel, we can see data of the 87 visits of this patient and the related lab test results from 1998 to 2012. Now we would like to visualize this dataset graphically. Let's see in the next slide how these data can be plotted in a graphical form. After the selection of the data, we can insert plot function with the format XY scatter plot. We obtain the following plot representation that we can appreciate data's several values of the variable eGFR are present for this patient, and that they are almost linearly distributed. This means that the reduction of eGFR with time is progressive and has a constant decay with time. From this data, we can derive some interesting clinical observations, such as the slope of renal functional loss with time. This is an example on how the data can be related to clinical history of the patient, even in a large database, and how it is possible to select and extract them for perform further analysis. In summary, we have seen how to join data from different sources in a database, in this case from different tables. We have seen how to select and extract data from a large dataset. Finally, we have seen how to export data from the database and how to analyze this dataset. In the other courses of this package, regarding data analysis, you can learn how to analyze clinical data in more detail. This analysis can be applied today to large data sets based on a large number of tables, what we call big data. Specific strategies must be adopted for the analyses of large data sets. This is the end of the present course. To complete the second module of the course, please answer the questionnaire on the course platform. This is necessary to finalize the course and also to allow us to evaluate your level of learning. We hope you found the course useful and that you will follow the other two courses on data analytics.